Welcome to Easy Math TV. This is part two of our videos on confidence intervals of a mean. So the first part, if you haven't seen that one, you'll want to go back and review that because you might not have caught some of the things we're going to be talking about here. Um, so go back and watch that one first and then come back to this one. So we're going to do one more example here, and this time we need to decide again whether we're going to be using the z or the t distribution for our mean estimation. So let's read the question. A random sample of 132 students from UNE showed an average of 52 likes on their Snapchat posts. The population, which is likes on Snapchat per user, is normally distributed with a standard deviation of 10.2. Using this information, construct a 92% confidence interval of the average number of likes of all UNE students on Snapchat. So there's a multi-part question here, just because it's important that we understand what we're actually doing. What is our goal? What are we trying to accomplish? And what are the important takeaways? So the first question is, what is the parameter of interest? And the answer to that, it's always going to be either, in this case, it's always going to be a proportion p or a mean mu, population mean. So let's go ahead and reveal that, and it is a population mean mu. We're not talking about the proportion of anything. We're talking about an average number of likes. So the average number of likes in among all students at UNE on Snapchat. Part two, what is the point estimate and give its value? So that's going to be, when we talk about point estimate, we're talking about based on our sample. Based on our sample, what is our best estimate of the true mean mu right now? So you'll notice we have a sample of 132 students, and we found from that that the average was 52 likes. So that's how we're going to express our answer is x bar, which is the average from our sample, equals 52. Next, find the margin of error of the estimate, which means we're going to find the confidence interval. Okay, so we're going to answer parts 3 and 4 at the same time since we're using StatCrunch. So this is where we have to make a decision. We have to decide whether we're using the t or the z. And now we have to read the question again and ask ourselves, is the sample size larger than 30? Um, I'm looking at this. We have a sample of 132, so check. Is the population normal? Well, there we have a statement here that it's normally distributed. Check. Do we know sigma? So even though it doesn't use the symbol for sigma, the statement here is that the population is normally distributed with a standard deviation of 10.2. So is the 10.2 tied to the sample or is it tied to the population? It's tied to the population. So that is a sigma value. 10.2 is a value of sigma, not S. And lastly, we know what our confidence level is. It's 92%. So we have all the information that we need to go ahead and enter what we know into StatCrunch, because there's our X bar 52, okay? So n equals 132, X bar equals 52, and sigma is 10.2, and our confidence level is 92%. So let's go ahead and put all that information up here. So I'm in StatCrunch now. And now I'm going to go to Stat and I'm going to Z stats instead of T stats. So Z stats, one sample with summary. Our sample mean is 52. Our sigma, our population standard deviation is 10.2. And our sample size is 132. And our goal is to get a confidence interval, and our level is 0.92. I'm always going to check this box that says show critical value because you never know if you're going to be asked for that. And I'm going to hit compute. So I really should zoom in on this a little bit. Let's zoom in and get that to be a bit larger. So notice that there's your N. This is a confidence interval for the true mean mu. Sample mean is 52. Standard error is 0.8878 if you round it to 4 decimal places. There's our critical Z, 1.75, and lower limit and upper limit, 50.4. Let's round it to 2 decimal places. So we have 50.45, and then the upper limit is 53.55. So both parts 3 and 4 here want us to round to 2 decimal places. So how did we calculate the margin of error before? We took our upper limit minus our lower limit and divided by 2. So 53.55 minus 50.45 divided by 2 is equal to 1.55. That's our margin of error. So, I'd say that's pretty good. It's not really wide. So give the confidence interval using interval notation. And if you recall, that means using parentheses. So, and putting the two numbers, lower limit first, comma, upper limit. So 50.45, comma, 53.55 with parentheses around it. Lastly, we're going to state our conclusion. So our conclusion is we are 92% confident that the average number of likes of all UNE students on Snapchat is between 50.45 and 53.55. Notice that's an average. We're not talking about the number of likes for an individual student at UNE. We're not talking about the average of a sample of UNE students. We're talking about the average number of likes of all UNE students on Snapchat. And that we're saying that we're 92% confident that that average is between 50.45 and 53.55. And that concludes our video series on confidence intervals in StatCrunch. Like, comment below, subscribe if you can. Um, you know, point other people in the direction of these videos. Make sure that you're sharing them with other people, okay? And especially if you think that they might find them helpful. And that's it. And then we'll go on to hypothesis testing next. See you in the next video.